Hi everyone, welcome to session. So I'm Akshit Kumar and I'm going to uh, discuss about the Java virtual thread. So let's start with some NashKnolX etiquette. So first one is punctuality. So join the session 5 minutes prior to the session start time. We start on time and conclude on time. And second is feedback. So make sure to submit a constructive feedback for all sessions as it is very helpful for the presenter. So silent mode, keep your mobile devices in silent mode. Feel free to move out of the session in case you need to attend an urgent call. And please avoid unwanted chit chat during the session. So let's start with the agenda. So first we will be covering the introduction to concurrency in Java. Then we will go for what are the virtual threads, why virtual threads, timeline of evaluation of virtual thread, classic and versus virtual threads. Then we will see some key benefits, use cases, and in last we will be covering the demo, and final we have the Q&A session. Okay, so let's start with the introduction to the concurrency in Java. So concurrency is the ability of a system to deal with multiple tasks at the same time, and it doesn't necessarily mean doing everything together, but rather managing multiple tasks efficiently. So why concurrency matters? So in today's landscape, concurrency is essential for its responsiveness. So like application that stay smooth while loading data or handling multiple user inputs, right? And second is scalability, so servers that handle thousands of requests without choking. And final, we can say efficiency, so systems that maximize CPU usage and minimize idle time. So let's start with the what is the virtual thread, right? So virtual threads are a new type of lightweight threads in Java that introduced as part of project Loom. So unlike traditional threads or the classic threads that are directly tied to the operating system threads, but virtual threads are managed by the JVM. So this makes them extremely cheap to create and maintain. So it's allowing application to run thousands or even millions of concurrent tasks without overwhelming the system resources. So the key idea is that virtual threads behave like normal Java threads, but they use the same API. Like we have threads, runnable interface, and the executor services, right? So developers don't need to learn a new programming model, right? So the difference lies in how they are implemented. Instead of blocking an OS thread, so when waiting for IO, input output threads, a virtual thread simply yields and freeing the underlying OS threads for other tasks. So mainly this solves a long standing issue in Java. Building the high concurrency application like servers, microservices, or message driven systems, right? So it used to require complex async codes like callbacks, compatible features, and reactive programming. But with virtual threads you can write simple synchronous code while still scaling to large number of concurrent users. So yeah, so next, why virtual threads? Yeah, so traditional Java threads are very heavyweights, right? So these threads are mapped directly to the OS level threads, which are expensive in terms of memory and CPU. So a single Java thread may require 1 MB of stack memory. So creating million of threads is like impractical, right? So to overcome this issue, developers often use asynchronous or reactive programming models like compatible feature, reactive streams, etc. But those come with complex and hard to manage code. So uh, virtual threads actually solve this problem. They are JVM managed lightweight threads. They can scale to million of concurrent tasks, and they they behave like normal Java threads, and it is easier to use, and it is like same API like we have the in classic threads. So they avoided blocking OS thread when a virtual thread waits for it's in IO, so it simply suspends and freeing the OS thread for other tasks. So yeah, so let's see an example of a web server handling the concurrent request. So when traditional threads, uh, if 10K users connect to the same time, at the same time, the server would need 10K threads, right? So each OS thread is heavy, so the system may run out of memory, and the context switching uh, overhead will slow it down. The context switching will be slow it down. But with virtual threads, the server can create 10K virtual threads easily. But uh, one thread waits for a database or network responses. So the JVM releases the underlying OS thread so that can be run smoothly. So, but with traditional threads, this would crash or slow down heavily. With virtual threads, it runs smoothly. So we can also see in the diagrams. So let's start with this traditional thread. So here we see traditional Java threads. Each threads has its own stack, OS level stack, which by default is around let's 1 MB. So this means creating thousand of threads quickly eats up memory, and context switching between them uh, will be costly. So that's why classic threads don't scale well beyond a few thousand threads on a typical server. But if it talks about the virtual thread, so here you can see the virtual threads, the JVM manage them, and so each thread actually uses a very teeny footprint memory. Because of this, we can run hundred of or thousand of virtual threads efficiently. And context switching also is lightweight because it's handled mostly by the JVM, not the OS. And you can also notice this curve of the traditional thread and the virtual thread. So here the um, curve of the traditional thread increasing uh, heavily, but where the virtual threads is taking minimum resources or minimum task, right? So in short, we can say virtual threads allow us to have threads of every task without worrying about memory or any OS limitations, while still using the familiar of the older our thread APIs like classic threads. So next, evaluation of the virtual threads in Project Loom. So in 2017, Project Loom actually announced by the Oracle to simplify concurrency in Java. And in 18 and 20, early prototype and discussion and announcement proposals is published. So next in Java 16, the first experimental preview of virtual threads is released, and in 19, preview feature available for the developers to test. So earlier in Java 16, it is not available for the test for the developers. And in Java 20, the second preview version with some improvement based on the feedbacks is released. And finally, in Java 21, the stable release of virtual threads is announced. So next is classic thread versus virtual thread. So where I already told about, like classic threads is very heavyweight, and it maps to the OS, right? So but classic threads works fine for like smaller workloads, but it hits limit quickly because they depend heavily on the operating system. But virtual threads on the other hand, they are actually JVM managed, so they are lightweight and scale much better, while still using the same programming model we are familiar with, right? So uh, classic threads is heavyweight, it uses high memory usage, expensive to create and manage, and also context switching between the operating systems, it is costly, and limited scalability, thousand of threads maximum. And where virtual threads lightweight and it's scheduled by the JVM, it's very small memory footprint, and it is very cheap to create. We can create a million of threads. And context switching also lightweight because it is done by the JVM, and scales, we can also scale it very easily for high concurrency applications. And it also uses the same thread API, it is backward compatible, we can say it is backward compatible. So there is some key benefits of virtual threads. So it is lightweight and scalable. It can create million of threads without exhausting the memory. Cheaper context switching because JVM handles it and making the concurrency faster. And improve the throughput, better handling of IO bound task. For an example, it is like DB calls and the HTTP request. And it simplified the code, no need for the complex async framework, and write the blocking code that scales. And it is backward compatible. We can use the older our methods and APIs. And better, next is the better resource utilization. So it keeps CPU busy while reducing idle wait times, and also it is developer friendly. Yeah, there is some use cases of virtual threads. So if we have the any web server or APIs, so it can handle thousands of concurrent clients request efficiently. So, and microservice, high throughput communication between the distributed services. It can manage thousands of concurrent blocking DB calls. It also handle large volume of concurrent tasks in event-driven system, and it can run many small tasks in parallel without heavy usage. So for testing and the simulation, so creating millions of lightweight threads to simulate high load to simulate the high load easily, right? So mainly virtual threads actually signs in IO heavy workloads. So if you can think about a web server that handling 100K requests, or a service that making thousands of database calls, with the traditional thread, this would choke the system. But with virtual thread, it scales effortlessly. Even in testing, you can simulate millions of users for tasks without crashing your machine. So, yeah. So before we start the demo, do you have any questions? Or should I move to demo? Okay, so let's start the demo. Yeah. So here you can notice there are two classes, one for the virtual, one for the classic thread, one for the virtual thread. So you can notice how the course looks almost identical, right? But there is only one difference. In above code we are using new thread, right? But in below we are using thread dot of virtual, right? So this is the beauty of virtual thread. So they can integrate seamlessly into the existing APIs, and the cost of creating thousands of these is very negligible compared to the classic threads. Okay, so uh, let me let's take another example of classic OS thread. So here you can see we have the we have take the task count of 100k, right? And the pool size is 100 for this. So here we are using the executor dot new fixed thread pool size, that is actually 100. And mm, uh, here we are using thread dot sleep for blocking the operations by sleeping for 10 ms, right? So every 10k task prints which thread executed it, along with the whether the thread is virtual or not. So the thread pool behavior will be like only 100 tasks can run at a time because of the pool size. So and the rest wait in the queue until the thread is not completed. So let me just run this. So you can see at every 10k task it is printing this, right? So the time is taken by this execution is almost 10k ms, right? So let's see. I will show you these threads in my machine. So let me just increase the mass. And in the stop, actually, I'm using the stop to see the threads in my machine. So let me run this again. And here we will be seeing these threads, running these threads. Okay, sometimes it take times. Okay, let me rerun it. Or let me check if thread is, yeah, this so custom thread names. Okay, so go back. Okay, let me restart this stop server. So we have to select the custom thread name, and it's not working. Yes. Okay, so let me rerun this code. Here we can see these threads. This is the pull thread one. Actually, it runs very quickly. So run again. So like this, you will be able to see the threads here. Right. So let's move to the next example. So here we have one example classic thread and second for the virtual thread. So now we will be running both the examples, and we will see the performance of this, right? Okay, so let me run the classic thread first. So you can see the like traditional thread taking time to run 10k 100k task, right? So it takes 10 almost 10k milliseconds, right? And in the same way, we will run the virtual thread. It also have the 100K task count, and let's execute this one as well. And here you can see it um, run it take time only 452 ms, right? So you can clearly see the difference, the performance of both the classic thread and the virtual thread. Yeah, so that's all. Any questions?
Hi Akshat, is your session done?
Yes, Sonalia.
Okay. However, we still have 25 minutes more to go. So I would request you to probably, explain the demo session a bit more, or you can have a Q&A session with your participants over here.
Yeah. So, anyone have any questions? You can go with the question. Q&A.
Akshat, you can ask questions from your end, considering whatever you have discussed from the PPT.
Okay. So, anyone can tell about the advantage of the virtual threads? Hello, I'm audible. Hello.
Yes, Akshat, you are audible. People who are on the call, can anybody of you answer to the question, since we all have attended the training? Sanjay, you are on unmute. So if at all you're speaking, we can't hear you.
So yeah, I'm repeating the question. So, what is the advantages of the virtual thread? What the benefits of it using it?
Hi Akshat. So the
Hi.
advantages of virtual threads are they are actually really lightweight and they are scalable, so they can actually concurrently handle
Mhm.
millions of tasks, large amount of tasks without having a high resource overhead.
Yeah, correct. So yeah, so my next question is, how do virtual threads actually interact with the with blocking I/O operations like JDBC, any or HTTP calls?
Am I
Salil, you
audible
can
now?
repeat a question.
Yeah. So
Somebody is on.
how do virtual threads actually interacting with the blocking operations, like any HTTP calls or any database calls? So let me give the answer of this question. So actually virtual threads handle the blocking IO. It actually parking instead of blocking. So when a virtual thread encounter a blocking IO operation, right? So example, it is waiting for a database response or HTTP reply. So it doesn't tie up with that underlying platform thread. Instead, the virtual thread actually is parked. It's mean like it is released for the other work. It is not waiting for uh, that particular call. It is released for that other work, and once it will get the response, it will return the response to the user or that service.
So Akshit, so they virtual threads actually handle blocking by suspending themselves and releasing the carrier thread, right?
So it is not canceling those thread. Is not suspending. Right. It's actually suspend those thread. Right. Yeah. And it is released those platform thread to do the other work. It is not
Yeah,
blocking
it'll
for
it'll suspend it, and at the same time the JVM can run other tasks on that particular
yeah,
carrier.
yeah, correct. Yes, correct. So next question, you can tell me any key benefits or any use cases of the virtual thread.
Sanjay, in case your audio is not working, you can type in an answer in the chat box. I don't think it's there in the recording. No? However, yes, you can repeat the question once again.
Akshit, you are
You're
on
on
mute.
mute, Akshat.
So the key benefits and any one use cases of the virtual thread.
Hi Akshat. One of the key benefit of virtual thread can be as compared to traditional threads, virtual threads require less memory,
Yeah.
as
And
well as
for yes, Abhay, please speak.
yeah, it virtual threads also allows blocking of the operations that can be handled efficiently.
Yeah, correct.
And about the real world example, we can take any example of any high concurrency web server or microservice that is handling lakhs and millions of simultaneous client requests. So virtual threads let each request run into their own thread without overwhelming the whole system.
Yeah, correct. And you can also take an example of WhatsApp, right? It is handling multiple users, right, at one time. So well, if you have any question, you can also ask related to this virtual thread.
Okay. So before we conclude, anybody has any questions? Okay, we'll take that as a no. Fine then. Thank you everyone for joining. Thanks a lot, Akshat, for taking the session. Thanks, Salil and Sabia, for giving the answers.
Yeah, thank you
Thanks
guys.
everyone. Thank you for joining.